Hello there. Today's lesson, this is Ms. Nakayama. Today's lesson is 2.2 Quadratic Functions. So we are going to review those things from Algebra 2 where you recognize characteristics of parabolas. You're going to graph them, determine a quadratic's maximum or minimum value, and then you're going to solve problems involving a quadratic's function max or min value. So first off, we're going to talk about what our book refers to as the standard form. You might have seen of it last year as the Vertex Form, but the standard form of a quadratic equation is f of x equals a times x minus h quantity squared plus k, where a, of course, cannot be 0. Now, what do you have to know about that? Surely you remember that the vertex is at that point hk, and that the parabola is symmetric to the line x equals h, or around the line x equals h, which is the x coordinate of the vertex always. Those will be the same number. Now, if a is positive, the parabola opens upward, and if a is negative, less than 0, then that parabola opens downward. So, the steps to graphing, okay? First off, you want to determine whether that parabola opens up or down. Okay, we just talked about it. If it opens up, if a is greater than 0, it opens up. If a is less than 0, it opens down. Next, you always have to find the vertex of the parabola. In this form, standard form, the vertex is hk. It's easy. Not always going to be that way. Then you're going to find any x-intercepts, and the x-intercepts are found when y is 0. So that means we're going to solve the equation f of x equals 0. And those real zeros are the x-intercepts. Then we're going to find the y-intercept by computing f of 0. And then we're going to connect all those points to make it look like, and they say a bowl, inverted bowl, but a parabola. So here's an example. I'm going over this very quickly, y'all, because if you have to know all the steps, and then I'm going to show you how you do it in my math lab. So if you want to remember, okay, pause the video, all right? But I'm going to go through it very quickly. So step 1, as we just said, determine how it opens. A is that number in front of the squared or on your x squared. So in this case, a is -1. That is less than 0. So I know my parabola is going to open downward. Finding the vertex. Vertex is at hk. In this case, h is 1 and k is 4. So my vertex is at 1, 4. Okay. The next step was to find the x-intercepts. Well, that was step 2, sorry. Okay, next, step 3, find the x-intercepts by solving f of x equals 0. Now, there's my equation, set it equal to 0. Okay, I'm moving the 4 over. Y'all, and I'm going through this very quickly, y'all, because you've already had this before, okay? So, x minus 1 equals plus or minus 2, which means that x minus 1 equals 2, or x minus 1 equals -2. Subtract 1 in each case, I get x equals 3, or excuse me, add 1 in each case, x equals 3 or x equals -1. Those are the x-intercepts. What's the other coordinate of the x-intercept? 0. So I have 3, 0 and -1, 0 as my x-intercepts. Next, I'm going to find the y-intercept. The y-intercept, generally pretty easy because I just have to compute f of 0, which means I'm going back to the original function and plugging in 0 wherever I see x. And when I simplify that, I get 3, which means that the y-intercept is 0, 3. Okay, and last but not least, we're going to go graph that. So when you graph it, as we just said, we know that the parabola is going to open down. Okay, and notice that those red dots are my x-intercepts. That blue dot is my y-intercept, and that green dot is the vertex. When you plot it in my lab math, y'all, you have to start with the vertex. So that's the first thing that we're always going to find. And then generally you just have to find one other point. But I'm going to do some examples so you'll see it. Okay, the other form of a parabola could be f of x equals ax squared plus bx plus c. All right, in this one, Not as easy to find the vertex, but I know y'all talked about it last year. It is equal to negative b over 2a and then f of negative b over 2a. That means go find this point and then plug it in this equation to find the corresponding y value. The x-coordinate is always negative b over 2a. And as I just said, the y-coordinate is found by substituting the x-coordinate into the equation and evaluating the function of the value at x. Okay? So, again, the steps. First thing we're always going to do, determine whether the parabola opens upward or downward. If A is positive, it opens up. If A is negative, it opens down. Next, always, you've got to determine the vertex. So if your parabola is in this form, I don't have an h and k, so I have to go find negative b over 2a and then plug it back in. Then, same thing we did before, finding the x-intercepts by solving the equation f of x equals 0. The real solutions of that equation are my x-intercepts. Okay? And the fourth step, again, same thing we did before, find the y-intercept by computing f of 0, but this is the easy one. So in one case, one part's easy. So in the other form, the vertex is easy to find, y-intercept, not as easy. Here, the y-intercept is easy because when you plug in 0, that's 0, that's 0, which means that my y-intercept is always c, okay? And it passes through that point 0c. And of course, you plot all those points and connect them. So here's an example. We have f of x equals negative x squared plus 4x plus 1. So step 1, as we did before, we're going to determine if the parabola, how it opens. I have negative x squared, which means a is negative 1. That is less than 0, so my parabola will open down. Step 2, find the vertex. The vertex is at negative b over 2a, so I'm going to go calculate that. Remember what my a, b, and c are, plug it into my formula, and find out that x is 2. So to continue with that, now I have to go find, because my coordinates are, find that x-coordinate and then go plug it in. We found that at x was 2, so I'm going to go plug it into the equation and find out that my vertex is now 2, 5. That was just a continuation of step 2. That was finding the vertex. So the vertex was a little more involved. The x-intercepts, when it looks like this, are a little bit harder to find also. We're still setting the equation equal to 0. And this particular equation that we have, y'all, not pretty, okay? So easiest thing to do was to do the quadratic formula that we talked about in that last lesson. So I'm going to find out that one x-intercept, plugging into my calculator, gives me negative 0.2, and the other one is 4.2. So my x-intercepts are, the other coordinate of each of these is 0. So negative 2, negative 0.2, comma 0, and 4.2, comma 0. All right, y-intercepts, we said that was the easier part. We get that by computing f of 0. Okay, step 4, and so I plug in 0 for x and find out that I get 1. So my y-intercept is 0, 1. And now I go put it all together on a graph. Step 5, we remembered, we found out the x-intercepts are in that red color. They are decimal values, but you know how to do that. Y-intercept is in blue. The vertex is in green. And the axis of symmetry is always an equation. So pay attention to that when we go into my lab math. So my math lab, my lab math. All right, these are the key steps, y'all. I'm going to tell you every single time you do this. If you know this, this is the easiest way to do it. So what I just told you is what you have to do if you have to do it by hand, okay? But if you get to do it, if you're doing it in my lab math, it's a lot easier. So I hope you'll appreciate that and do all the practice problems, okay? You always have to determine whether it goes up or down. You always have to find the vertex. That's either going to be hk or negative b over 2a and plug it back in. And then you always have to find that y. You should always find that y-intercept because that's generally the easiest one to find, okay? So I'm going to go into my lab math and do some examples. So the first one that you look is like this is in vertex form. okay? And you have to match each of these equations with the graph. So if I look at this parabola is going up, and its vertex, h, is -4 and k is 1. That's not -4, 1. That looks like -4, 1, and it is the only one. So I know that it's going to go here, and you just got to drag it there, okay? This has a vertex of 4, 1. Well, that looks like 4, 1, and these two are not, so I'm good with that one. And it didn't want to go. Come on. Come on. There we go. This is -4, -1. So -4, -1 is here. And then 4, -1 is right here. And it won't go. Come on, there we go. Check your answer. And that's incorrect. Way to go. What did we do wrong? Y'all weren't sitting there making sure I was, oh, this one says -1. These two are backwards. I mean, mixed up. There we go. Let's try that. Boom. Okay? Easy fix. Shouldn't be too difficult. Making sure you know how to find the vertex in that standard form. Okay? Let's look at number 2. All right. These are not in that standard form. It's not as easy to find the vertex. However, so what you want to look at, first of all, does it go up or down? Because we have one that goes down. So which of these goes down? The one that has the leading coefficients negative. So boom. Come on. Okay. And now I have, so this one here, if you notice, this is kind of what we did in the chapter we just did, and that's y = x squared shifted down 4. So that's my parent function, just shifted down. This has been shifted left. That's been shifted right. So this one is going to go here. Oh, jeepers. What is it? There we go. And now this one is shifted left. So if you look at these, the only difference in these two, they both have a y-intercept of 4, but that is a -4x and that has a +4x. So if you were to put it in the vertex form, then it would be x minus something, which means this guy's going to move to the right. So he is going to go here. If I can get him to stay, there we go. And this one will go here because he doesn't like me. Oh my goodness. Whatever. All right. Check our answer. We're good to go. All right. So that's what you have to do in the beginning. And then there are some that you actually have to graph. So in this particular one, use the vertex intercepts to sketch the graph of the quadratic. Give the equation for the parabola's axis of symmetry. Use the equation to identify the function's domain and range. So these are the steps that I was talking about here. Determine if it goes up or down. Find that vertex depending on the form. And then find the y-intercept. So my graph is going to go up. And my vertex, y'all know, is 1, -1. I'm going to choose my parabola tool and go to 1, -1. And now I will tell you, you can usually go over 1, up 1, or you can go plot the y-intercept. But that's, I mean, you can go find the y-intercept, okay? You can plug in 0, or you can go, know that a value says I'm going to go over 1, I'm going to go up 3. So I'm going to say that's where it is. If you plug in 0, 0 minus 1 is -1, squared is 1, 3 minus 1 is 2. And did I graph that? 0, 1, 2. That's where I graphed it. So I know that's right, and he wants me to check my answer. So we did. Make sure you answer all the parts. The axis of symmetry, type an equation. So I'm telling you, if you do not put an equation, y'all, it is always x equals a number. In this case, it's that part that's squared, x equals 1. If you set that equal to 0, you'll find out what it is. Okay? But if you don't have an equation, it's going to mark it wrong. The domain, every quadratic, the domain is going to be negative, I didn't type that, negative infinity to positive infinity for every parabola in this chapter. The range is tied to that vertex. So the lowest point is -1, and then it goes on forever and ever. So I'm going to have bracket -1, and then it goes on forever and ever. and then I have a parentheses. And that's all we got. Okay, and one more doing the same type of thing, but this is a different, it's not in that vertex form. So we have to go figure out negative b over 2a. And negative b over 2a is, you can do that, pause the video, see if you get it right, come back. Negative b over 2a is negative 1/2. And when you plug negative 1/2 in here, you're going to have 1/4 minus 1/2 minus 2, which is negative 9/4. So I'm going to go plug in negative 1/2. This is negative 1. So that's negative 1/2. And then 9/4 is 2 1/4. So it's here. And then your y-intercept is easy. It's negative 2. So boom. Check my answer. Great. My axis of symmetry, it tells you, y'all, it tells you right here, type an equation. X equals, and that was negative b over 2a, so that was negative 1/2. And what else do they want from us? They want the domain. All right, I told you every domain in this, as we are doing these parabolas, negative infinity to positive infinity. And then we have to give the range. Again, this guy's going up, so that's the lowest point, and it was tied to that vertex number. So remember, it is always equal to that vertex. So I had negative 9/4 all the way up forever and ever to infinity with the parentheses. Okay. And that's how you graph in MyMathLab and the different types of equations you have. All right, to go back and finish, we got to talk about the applications, okay? We have talked about this before, y'all. You know where the max and mins are. And as we just saw, if A is positive, then you know your graph is going to have a minimum. And if A is negative, you're going to have a maximum, okay? You might write this down. It's kind of important, okay? Every application of a quadratic, most of the time, is solved at the vertex. That's my vertex formula. Negative b over 2a, comma, f of negative b over 2a, also known as hk, depends on what your equation looks like. But whenever you're answering questions, remember that the x coordinate tells you where it happens, the location of the max or min, and the y coordinate tells us what that value is. Okay, you just did that on your test from the last chapter, and I hope you got it all right. So look at this problem. Consider the quadratic function 4x squared minus 16x plus 1,000. Determine without graphing whether the function has a minimum or maximum value. So I determine that by looking at my a value. A is 4. That is greater than 0, which means my parabola is going to go up. Therefore, my function will have a minimum value at the vertex. Now they want us to find that minimum value and determine where it occurs, okay? It's going to occur, where it occurs is the h value of my vertex, and the value itself is the k value. So the first thing I have to do is go find the h value of my vertex. So what is that? Negative b over 2a. And in this particular function, that's going to be, what do we have? Negative b is going to look like that over 2a, and that simplifies to 2. Okay, so where does the max or min? Well, we already determined it was the min. Okay, we answered that from part 1. Okay, so where does the minimum occur? At x equal to 2. What is the minimum? I got to go put that into the original function. So everywhere I see an x, I'm plugging in 2, and I'm going to simplify that and find out that f of 2 is 948. So the minimum value is 948, okay? To give the domain and range, we just talked about this. Domain is always the same, negative infinity to positive infinity. The range, okay? So this is my vertex, 2, 948. That's this point right here. And so that means that my range is going to be lowest value is equal to 948, and the highest value is infinity. And that's our range. All right, one more thing talking about the strategy for solving problems. Okay, make sure that you read the problem carefully, decide what's going to be maximized or minimized. Use the conditions of the problem. If you have to write a function, okay, you're going to write it in one variable. Make sure it looks like this quadratic form that we're used to, and then you're going to find the vertex and then answer the question. So you just got to make sure you answer the question. So here's an example of one, and I picked an easier one, and most of your homework's like that. You actually don't have to write the equation. You're going to be given it in the problem. An athlete whose event is the shot put releases a shot. When the shot whose path is shown by the graph to the right is released at an angle of 65 degrees, its height f of x in feet can be modeled by this function, where x is the shot's horizontal distance in feet from the point of the release. Use this model to solve parts A through C and verify your answers with the graph. So here's the graph. What is the maximum height, y'all? If they're asking us the max or min in a problem, we have got to find the vertex. Okay, so I'm going to go back up to this problem and remember that this is A, this is B, this is C. I've got to find the vertex. To find the vertex in that form, I've got to do negative B over 2A. So that means that negative B, negative 2.1 over 2A is negative 0.3. And when I simplify that, I get 35. Okay, and now to find the y-coordinate of my vertex, I'm going to go plug in 35 everywhere I see x in that function, and I'm going to simplify that to 42.95. So what is the maximum height of the shot, and how far from its point of release does this occur? The maximum height, is that x or y? I hope you told me that was the y-coordinate. It's 42.95, and which occurs how many feet from the point of its release? That would be the x-coordinate of your vertex. Okay, notice here, type an integer or decimal rounded to 4 decimal places. You need to read this little blueprint every time you do these problems, y'all, because that's what it's going to decide whether it's counting things right or wrong for you. All right, what is the shot's maximum horizontal distance? Well, here's its horizontal distance. If they want the maximum, they're looking for this value right here, which is my X-intercept. And the X-intercept occurs when this function is equal to 0. So I'm going to set it equal to 0 and use my quadratic formula, which is going to look like this when I plug in my A, B, and C. And when I simplify that, okay, I'm going to get x is equal to negative 2.8. Well, that would be the number if I kept on going over here. That would be negative 2.8. That makes sense. Okay, let's look at the other number I got. 72.8. And according to my graph, this is how you can kind of check your answer. Well, that's 60, that's 70, and that's 80. So that's a reasonable, 72.8 is a reasonable number that I got. And that, of course, is the maximum horizontal distance. It does say, from what height was the shot released? Okay, well, it was released right here, y'all. So it's the answer to that is some number less than 10, and I hope you're telling me and know that this is the y-intercept of my graph. Okay, so from what height it was released means I want to know when x was 0, and x is 0 at the y-intercept. In this case, 0c, so my answer is 6.2. So that was long, but I hope that you paused it when you needed to and write down those important formulas to remember them, so that when you do your homework, it's not very hard. Thank you so much for watching, and y'all have a great day.